Okay, continuing with converting polar equations to rectangular form. Here's a couple other samples similar to what we did in the previous video. So again, we have we have secant here, but we don't have secant in our formula, so we're going to change this, use the reciprocal property. So this would be 2 over cosine theta, and then we're going to multiply both sides by cosine theta. Multiply this by cosine theta. Oh, that's looking terrible. Cosine theta. That's going to give us our r cosine theta equals 2, and r cosine theta equals x, so x equals 2, and we have ourselves a vertical line. All right, coming over here, we have theta equals pi over 6. We know that theta equals arctan of y over x. So we can say that arctangent y over x equals 11 pi over 6. Well, yeah, that's right. I guess we should have said xy equals tangent of 11 pi over 6, right? Because the arctangent of this values of this angle is going to be, or the value is going to be that angle. Okay, so tangent of 11 pi over 6 equals x over y. Tangent of 11 pi over 6 is negative root 3 over 3. So y over x. So solve for y. Y equals negative root 3 over 3 times x. So we have a line. Okay. Over here, these get a little bit trickier. We're going to if we want to say r over 1 and cross multiply, however you want to think of that about it, or say I'm going to just multiply both sides by 1 over cosine x. But basically we get r times 1 plus cosine theta equals 2. And we multiply the r in, or distribute the r in, so r times 1 is r plus r cosine theta equals 2. All right, r equals the square root of x squared plus y squared. So we're going to substitute that in for it. We want to get rid of all the r's and all the thetas. R times cosine x, that equals x. So this is plus x equals 2. I'm going to bring the x over to the other side. So I have square root of x squared plus y squared equals to 2 minus x. I'm doing that because I want to square this, and I didn't want to square it here because that gets really ugly. But if I bring it over, and if I bring that x over, now I'm squaring this. It's a little less ugly. And now I also have to square this side. If I square one side, square the other. So on the left side here, square root of x squared plus y squared, that cancels out, just leaves me with x squared plus y squared. And I come over here and I have to multiply this out, and we've got, again, this is 2 minus x, 2 minus x. So that's 4 minus 2x plus x squared. So this is 4 minus 4x plus x squared. Now, if I were to subtract x squared from one side, I have to subtract it from the other side. It's going to cancel out. So my x squares cancel out. These cancel out. That leaves me with y squared equals, I'm going to rewrite this in the right order, negative 4x plus 4. That's this part right here. That is a parabola. Another way to write it would be y squared equals negative 4x plus, no, x minus 1. We're distributing out a negative 4, so minus 1. So if I put that in, if I distribute that in, that'd be negative 4x, and that'd be positive 4. You should know, looking at this, that this is going to be a parabola opening to the left, okay? It's opening left and right, since it's a y squared that's, since it's y squared, opening left or right. Since it's negative, it's opening left. That was from last chapter. Okay, this problem is exactly the same thing. Just take r times 1 minus sine theta equals 3. R minus r sine theta equals 3. So substitute square root of x squared plus y squared for the r. And then over here we go minus y equals 3. X squared plus y squared equals 3 plus y. Do that same thing where we square both sides. We have x squared plus y squared equals 9 plus 3y plus y squared. The y squares are going to cancel out. It leaves me with x squared equals 3y plus 9, or x squared equals 3y plus 3. This is a parabola. This is a parabola opening up. All right, that's it. All right, the next part here is going from rectangular to polar. So rectangular to polar. Key formulas: r squared equals x squared plus y squared. Okay, that's the same as saying r equals. Okay, it's just another way of saying it. And then we're going to use this x equals r times cosine theta, and y equals r times sine theta. So same formula as we used before. Come over here. Now we go on anywhere we have x's and y's, we want to replace it with r's and thetas. So y equals, over here, y equals r times sine theta equals negative 2. I'm going to divide. I want to get it by r by itself. When we have polar equations, they're always going to either be an r by itself or it's going to be a theta by itself. So r equals or theta equals. So in this case, r equals negative 2 sine theta. And that's how you'd want to leave it if you wanted to actually plot points and find r, because you're going to take the sine of different angles. But the sort of more simplified way of writing it would be negative 2 cosecant theta. But if we're going to plot the points to see what shape it would be, we would use the r equals negative sine over, or negative 2 over sine theta. All right, come over here again. We're going to replace all the, we're going to replace x's with, so 4r times cosine theta plus 7 times r times sine theta minus 2 equals 0. We'll just, let's see, let's do this. Let's move this over. Let's move the 2 over, since it didn't have equals 2. Now we can take the r in both of these terms and we can factor that out. So we have r times 4 cosine theta plus 7 sine theta equals 2. And again, we just want to isolate the r, so we're going to divide everything else out. R equals 2 over cosine theta plus 7 sine theta. And there's nothing else we can really do with that. Okay, last one here. Let's see. We know, look at this, x squared plus y squared. Well, that equals r squared. So let's come over here and we're going to make this r squared minus 8 times r sine theta equals 0. We're going to r squared equals 8r sine theta. I'm going to divide both sides by r, and that leaves me r equals 8 sine theta. All right, is that it? Where'd it go? Yep, that's it for 9.6.